A cycloconverter thyristor relies on a fragile silicon wafer clamped between heat sinks by a spring bar. Underclamping leaves gaps, and arc heat melts the component. Overclamping snaps the wafer. Never use a torque wrench. Measure the spring bar's bend with a dial gauge. Replacing a thyristor is a precision calibration, not a mechanical wrenching job. The component only survives if you hit the exact deflection target. Preparation starts with the mating surfaces. You clean the heat sinks and the new thyristor by gently abrading them in circular motions with a nylon sponge, wiping them down with methanol, and applying G322L heat-conducting compound. But you have to be careful. Scrubbing too aggressively will strip the protective plating and expose the raw copper underneath. If you see copper, the thermal profile is ruined, and that heat sink must be replaced. Once properly prepped and wiped clean, you apply a thin, uniform layer of the compound to ensure perfect thermal transfer. Next, you position the thyristor, centering it precisely between the upper and lower cooling elements. When applying the clamp, tightening one bolt fully before moving to the other creates a shear angle. That uneven pressure distribution will fracture the wafer before the drive ever powers up. Instead, you tighten the bolts symmetrically, alternating sides until they are just finger tight. Then use a sliding caliper to confirm the spring bar is perfectly parallel to the heatsink with zero deflection. Establishing this parallel, unbent baseline is critical. It creates the true zero you need to accurately measure clamping force moving forward. Now you attach the dial indicator deflection gauge, part number 57198028, directly to the clamp. As you tighten the bolts further, this gauge translates the microscopic bend of the spring bar into a precise reading. To achieve the correct clamping force accurately, you consult the OEM manual. This table shows every thyristor type alongside its required force in kilonewtons and its corresponding spring bar deflection target in millimeters. Let's test this. Look at the chart and identify the required force and target deflection for a 5STP3842N thyristor using an SLZF174-100 clamp. The manual dictates 90 kilonewtons of required force, which translates directly to a 0.36 millimeter deflection target on the dial gauge. You can't see or feel kilonewtons of force by hand. Measuring the physical deflection in millimeters is the only way to prove you've clamped the device correctly. For the 3842N thyristor, apply alternating, symmetrical turns to the bolts, left side, then right side, in small increments. The dial indicator climbs steadily. Watch the gauge, not your hands. When that needle hits exactly 0.36 millimeters, stop. You've applied exactly 90 kilonewtons of force. Here's your procedure. 1. Prep with a nylon sponge, never exposing copper. 2. Mount symmetrically until tight, verifying the spring bar is perfectly parallel. 3. Look up the targets in the OEM table. 4. Tighten to the exact millimeter target on the dial indicator. Following this deflection-based process removes all mechanical guesswork. It ensures the fragile silicone wafer can withstand the extreme electrical loads of startup.